So the next question is, what is the probability of getting a sum of 5 with 2 dice? Now, as we know that each dice has 6 combinations which are independent. So the combination can be 1, 1. So in both the dice we get 1. 1, 2 means in one dice we get 1 and another dice we get 2. 1, 3 means first dice got 1 and the second dice got 3, and so on. In that way we can create like 36 possible outcomes can be possible. 36. So there can be 36 combinations can be possible with 2 dices. Now the question is asking what is the probability of getting a sum of 5. So the sum of 5 can only be possible when first dice get 1 and the second dice get 4, or maybe vice versa. Or the other scenario could be when the first dice get 2 and the second dice get 3, or vice versa. So as you can see that there are only 4 possible ways we can get 5 from the 2 dice. So the probability of rolling a pair of dice whose number add to 5 is 4 divided by 36. So 4, and out of the 36 combinations, 4 can give us a sum of 5. So the probability becomes 4 divided by 36 equal to 1 divided by 9. Now it's asking like what is the probability of rolling at least 1 6 with 2 dices. So we saw in the previous question also that with 2 dices we have like a 36 combinations can be possible. 36 combinations, and we can see out of those 36 combinations, the yellowish one can be the possible outcomes. So 1, 6, 2, 6, 3, 6, 4, 6, 5, 6, because at least one dice has a 6 in it. Or the other possible can be 6, 1, 6, 2, 6, 3, 6, 5, 6, 6, because all of these yellowish one have at least one 6 in it. So therefore the total number of combination can become like 36. 6 into 6 equal to 36. So the probability of getting at least 1 6 with 2 dice will become 11 divided by 36. So if you count the yellowish one, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 11 divided by 36 is the probability. So in the next question, let's say a car company has produces 2 cars, car X and car Y. Now they have also developed 2 technologies to reduce gasoline usage. Now the technology A has been implemented on the car X, and technology B has been implemented on car Y. Now the benefits what we have seen in both the technologies are as follows. So for technology A, the miles per gallon of car X has increased from 50 miles per gallon to 75 miles per gallon. And similarly for in technology B, the car Y miles per gallon has increased from 10 to 11. Now the question is which technology a company should take or use to save the most gasoline for the country. Now in order to solve this problem, first of all let's define the distance. So let's say we are putting a constant distance for both the technologies. So let's say put the distance for car is D. So we will see which technology saved the gasoline most in distance D. So both the cars will drive the same amount of distance D. Now we are defining the total gas usage, like how much gas has been used. That will be calculated based on total distance covered divided by the miles per gallon. So this way we'll come to know how much gas has been used in commuting a distance D. Now let's calculate for technology A, how much gas has been used. So it's saying that for technology A, the miles per gallon has increased from 50 to 75. So using the formula what we have defined, D divided by MPG, we will put it as D divided by 50 minus D divided by 75. We will come out to be D divided by 150. That's the gasoline or gas usage have changed after implementing technology A. Similarly, we can also calculate how much total gas has been used when we implement the technology B. And it's saying that for technology B, miles per gallon has increased from 10 to 11. So in that way, we can put it as D divided by 10 minus D divided by 11. That come out to be D110. That's our total gas usage have changed after implementing the technology B in car Y. Now we can see that denominator is less for technology B, which is 110, because our numerator is same. So we can say that therefore the biggest change in the gas usage has been seen for technology B. So we can say that technology B, if we use technology B, we have seen that total usage is less for technology B. So henceforth, the biggest change we have seen in the gas usage is for technology B. So the next question is, you have given a dice and you need to tell how many on an average, or what would be the expected number of dice rolls are required to get 2 consecutive 6. So let's say the expected number of dice rolls are required is X. And let's break down this problem into multiple scenarios. Let's check the first scenario. So let's assume that in your first roll you have not got a 6. You have got some different number, maybe between 1 to 5. Then we have wasted that particular roll. Now the probability of this event to be happened is 5 by 6, because there are 6 possible outcomes, and if 6 is not coming, then the probability would be 5 out of 6. Now the total number of rolls required is X plus 1. Now the next scenario could be that let's say you're lucky and in the first roll you got a 6. And let's say in the second roll you didn't get a 6, you got some different number. Then I can say that you have wasted 2 rolls, because we wanted to have a 2 consecutive 6. Now this particular turns are gone. Now the probability of this event to happen is, for the first roll to get a 6 would be 1 out of 6, 1 by 6. And for the second roll to not get a 6 would be 5 by 6. So when we multiply 1 by 6 into 5 by 6, that will come out to be 5 divided by 36. So 5 divided by 36 means that in your first turn, or in your first roll, you will get a 6, but in your second roll you will not get a 6. So it means you have wasted 2 rolls, and that probability of this event would be 5 divided by 36. So it means now the total number of rolls required would be X plus 2. X plus 2. Now let's say the third scenario, and let's say you are very lucky and fortunate, because in your first roll you got a 6, and even in your second flip or a second roll you also got a 6. Then we are done. So the probability of this event would be 1 by 6 into 1 by 6, because in your first roll you are getting a 6, that probability would be 1 divided by 6. And similarly, to get a 6 in your second flip as well, that probability would be also 1 by 6. So that will become 1 divided by 36, and the total number of rolls required are 2. So these would be some of the scenarios could be possible. Now let's see how can we combine all the 3 scenarios into one, and then see what would be the value of that X. Now let's add all the 3 scenarios into this equation. So total number of expected dice would be X. So we are putting here X equal to, now we are combining all the 3 scenarios into one. So the first scenario was 5 by 6, that is the probability, into X plus 1. That's what we are doing, 5 by 6 into X plus 1. Now in the second scenario, the probability of that scenario to happen is 5 by 36 into X plus 2. So that's what we have done, plus 5 by 36 into X plus 2. And then similarly, the probability of a third event to happen is 1 by 36, and the total rolls required is 2. So it becomes plus 1 by 36 into 2. So if you solve this equation, you will get the value of X equal to 2. So it means the expected number of dice rolls required to get 2 consecutive 6 is 42.